environmental engineering. Thank you very much for giving me the opportunity. Thank you.
Thank you very much, ma'am, for your inspiring words. Now, it is my privilege to welcome Professor S. Mohan, Professor and former Head of Environmental and Water Resource Engineering, Department of Civil Engineering, IIT Madras, to share his esteemed thoughts. Sir, please.
Am I audible?
Yes, sir. Yes.
Yes, sir. Yes.
Okay. My slide is visible there?
Yes, sir.
Yes, sir.
Yes,
It is.
yes, sir. Visible.
Visible.
Yes. And it
Okay.
is changing also.
No, I put the first slide.
Yes. Now this is.
Now is it okay?
Yes.
Yeah. Very good afternoon. First of all, thank you, Professor Sridevi, for inviting me to participate in this FTP program. And I should also thank Professor Krishna Reddy, who made me to be more comfortable with the geo-environmental engineering. So this topic, what I am going to talk about, is on geo-environmental engineering. I have been working in IIT Madras for a last 37 years, and recently I retired from that. But at the same time, I had uh, worked on the landfill for the last 20 years on both Andhra Pradesh and also from Tamil Nadu. The landfill have been designed, vetted by our group, especially geotechnical group and so on. So I just wanted to give an important problem uh, like municipal solid waste open dump site remediation. So this is one of the major issue that our country and many developing countries and also developed countries have been facing about it. So I plan my lecture like this: introduction, municipal solid waste in India, the challenges due to open dumping. Then, as a case study, we have done the analysis of the municipal solid waste and how to give the solution. Not only telling about the problem, but we should also give the solution. So finally, I will say a few words about way forward and life and environment. So this will be a very generic kind of advice for especially young people who are going to do a lot of research work here. So the facts of municipal waste, solid waste in India, almost around 182,000 tons per day of solid waste is generated across urban India. And Maharashtra tops with the list higher, Uttar Pradesh and Tamil Nadu is on the third one. And of that, 80% is collected and only 20% about is treated. So the rest is often cruelly dumped. And there is cruelly dumped means it's a kind of an open dumping without any kind of protective measures. And the per capita waste generation is also increasing over the years, and especially at the rate of 1.3% per annum. And uh, whereas the urban population is 3 to 3.5, so almost half of it that it is also waste generation is increasing. So per capita waste generation is around 500 grams per capita per day, but the city average waste in generation, especially in Chennai, it goes up to 750 grams. So almost nearing 1 kg per capita per day. So for everyone is generating around 1 kg per capita per day. The still almost 75% municipal authorities are continually dumping their municipal waste in unhygienic manner, leading to health issues and environmental degradation. So actually, if you look at the WHO, there are around 25 type of diseases that can be prevented if we are good in solid waste management in India. And in fact, if you look at it, every day we are almost 2 hectares of precious land would be lost, which amounts to 730 hectares per year. And these are all city limit, and sometimes it is at the center of the city also it is there. So you can imagine almost around 100 crore that it is being wasted because of this, because we are not managing that particular thing in a clear way. If immediate remedial action is not taken, cities will not be allowed to waste so much farmland as evident from agitation, because many villages are against this. And if you look at the generation, the urban is 72, and in that, and 6 cities alone is around 21% of the waste, whereas rural India is only 7%. That means the urban India itself is around 93% that they are generating it. And in the city, if you look at it, Kolkata 4, Chennai 3, Bangalore 2, Hyderabad 2, Delhi, even though Delhi is very small compared to these cities, but they generate more waste. And Mumbai is almost 6. So that means in the cities, we are generating a lot of waste than even the rural India, mainly because they recycle and reuse, whereas we don't do anything. And why we are really looking at this thing as an important thing? One is we don't have a plan. We just dump it, assuming that nothing will happen, but that creates a problem. And scavenging by the rack pickers, waterlogging and leaching through monsoon, causing heavy metal pollution, dust nuisance due to vehicular movement, and this NIMBY principle is very much prevailing, especially in our country. That means it is not in my house or not in my backyard, so I just throw it out. So there are odor and fly nuisance, no confinement of the waste body, uncontrolled burning of waste, emanating smoke and other air pollution. So now, thanks to Government of India, they have started with Swachh Bharat Mission 2. And in that, one of the major thing is dump site remediation. So if you want to write for a project, I think this is one of the good area that we can write, because we have a lot of dump sites in our country. So almost around 3,200 dump sites and are available, and offshoot of the waste mismanagement for our decade, almost around 10,000 hectares over the next 5 years as such. So even though we have a legal mandate by the solid waste management rules, investigate and analyze all open dump sites for their potential for biomining and bioremediation, and take necessary action to biomine or bioremediate the site. So this itself is a good area for you to do research. So we can go ahead both in geotechnical survey or geo-environmental. I think this is one of the major problems that you can take. And also you have a good satisfaction that you are trying to solve some problem which is just right below your nose. So you can just see the dump site. Uttar Pradesh is around 611. Madhya Pradesh is 328. Maharashtra is 327, and you can, so only Lakshadweep is not having any dump site, of course. That's a small area. So that means we are almost everywhere there are Even Tripura has 4, Goa 9, and Chhattisgarh 8, Meghalaya 6, and Delhi 3. Delhi 3 is very big sites as such. So the dump site only reclaimed or capped is only 87. And still there are many dump sites which are need to be given. And whereas some dump sites which have been converted into a good landfill is only 14. So you can imagine 3,200 thing out of that only 14 plus 87 has come. So still more than 3,000 dump sites are there, which which is causing a lot of problems in our country. So this we call it as a legacy waste. Legacy waste is the waste which has been there for a long period of time. Okay. So the aged municipal solid waste, partly or completely undecomposed waste, contains scrap, polymeric and combustible material and also inerts. So sorry. So this legacy waste need to be get rid of it or do something, make it as a thing. So we will see later how we can solve this particular problem. So there are challenges because of this dump site. The environment challenges is open dumps where the waste is dumped in an uncontrolled manner. Provision for leachate and gas control system do not exist. So anything what it comes out is going to be a problem in your air pollution, and also it goes into the groundwater where the leachate. Most of the disposal sites are unfenced and open firing of municipal solid waste is very common. So this firing is being done to get some scrap material which are there like iron and other kind of. Hello. Yeah, I'm in a meeting. Can I call you later? Uh, the wasted recyclable materials have lost inherent energy from production, and leachate from unlined and uncovered dump site contaminates groundwater as well as surface water, especially sometimes the volatilized heavy metals like mercury and lead, dioxin and furan from open burning dump sites and low standard, because we have dioxin, there are chlorine or that when it is started burning, then it becomes a big issue. And the crude dumping encourages breeding of insects and rodents, and open dump sites are top resources for methane and N21 CO2. And methane has 20 times the potential than the CO2. So if you talk about the global warming or climate change or greenhouse effect, I think this is the most important site where the CH4 is emanating from the, and bioaerosols and dust from handling and smoke particulates from open dumping. So in a simple word, if you want to see water pollution, air pollution, land pollution, the dump site is one example where all pollutions are available. So that means we have to take care of little more better way to do that. The second is on health challenges. There is a lot of infection, animal diseases, and respiratory diseases because of the bioaerosol, cancer, those who are living. In fact, there was a good research. Those who are rack pickers, those who are here, they never live beyond 45. That means very unfortunate people because they have been uh, swallowing or taking these breathing, these particular dioxin and other things. So they get the cancer, of course, headache, injury. There are many things. So health challenges are very much in these unscientific dump sites. And even the bird flu or the mad cow and all other things, it was started from the open dump site like this, especially from pig kind of animals. So if 1 ton of municipal solid waste is there and you are just dumping it without any capture, so it will come out with 1610 kg of CO2 equivalent that it comes out. And that means you can just see 1 ton and 16 ton kg. And 16 ton kg is 1.610 kg of or tons of CO2. So even though municipal solid waste is 1 ton and we get 1.61 tons of CO2 what it comes. And this CO2 is the main reason. And we have the gas, water, fire, everything that it comes over here, and the surface water contamination, groundwater contamination, all those. And especially the CH4 emission is very high at these particular dump sites. So socioeconomic challenges, the limited land availability with the urban local bodies. So because huge lands are locked up in dump site, in fact, many times that people are arguing for more site for dumping the solid waste. Neighborhood land cost depreciation due to public nuisance. Neighborhood residents face various health issues, and neighborhood socially disadvantaged with respect to others create a bad impression about the local government, and also it is unhygienic. So it has environmental challenges, it has the health challenges, and also the socio-economic challenges as such. And on the governance, that is much more difficult. So coordination disputes, Panchayat Raj and municipality, and similar coordination between state and urban local bodies, and legal disputes. There were a lot of public interest litigations on this. So this is one area where there is a lot of scope that environmental, geotechnical engineers, and also the other engineers to come out with a good solutions for this, which is happening over the longer time. And we have been, we are not, we know that it's a problem, but nobody works on this particular thing. So the opportunity is, there is a good opportunity, only less than 5% is scientifically managed. That means 95% of the things that there is a possibility that we can develop some kind of a thing to solve this problem. And uh, there are many ways of solution, public-private partnership, willingness to pay, state government with central government support, Swachh Bharat program, and we can also develop compost incentives, favorable power tariff for waste to energy and monitoring. So there are good possibility that you can also write some projects based on some of these areas or combination of these areas as well. So let me take a case study, because we have to give some example why this is a problem. In Chennai city, as far as 2022 is concerned, it is around 6,500 tons per day. 1 ton is 1,000 kg. You can imagine how much solid waste that it comes out. And they divided into two, one dump site on the north and one dump site on the south asset. So one, it is receiving around 3,350, another is 3,150 of garbage from 6 to 10. So the dump site has been operation in from 1985, and almost around 162 hectares that being utilized in one dump site. And all these dump sites, almost more than 64 hectares that has been, 162 is earmarked for both the sides, and 64 is with a depth of 3 to 5 meter what it is there. The characterization for this Chennai is there is no segregation. So that's one of the major issues that we can't find a solution. Scientific and systematic storage of waste at source, that also is not in practice, except some 3 or 4 wards. Open and large drains passing across the city, and don't take the waste to the designated points, and no processing, no adherence to any standard. The dump site are not scientifically managed. This is a thing. You have food waste is around 8, green waste is 32.25, and this itself you can reuse it for composting and so on. But we don't do. We all send that back to the dump site. Timber 7%, consumable plastic is around 5.6%, and industrial plastic is around another 1.18. So totally around 7%. Steel and material, wax, textile. If you look at it, these are all can be recycled. Only the green waste and food waste can go to compost, provided that we come out with a way to separate these waste assets. But what we do is we mix everything together in one place. That is the major issue that we are facing it in our, not only in Chennai, but also in all the places. So this is a study area where the dump site is there, and we took a lot of samples, water samples, soil samples, and so on. I'll just talk about on the water samples. So you can just see the groundwater characteristics at these particular places. So let us say lead. The lead is the maximum limit is 0.01. But you can just see here it is 0.052 the minimum. 2006 and 2022 it is around varying from 0.76. 0.01 is a limit, but 0.76. Like that, chromium and also the other thing. Mainly the manganese, lead, chromium. These are the more importantly. The lead is, it will affect the kidney and also your nervous problem and so on. And similarly, the chromium also, the chromium will have such a bad effect in the thing that we may not be able to do the normal work in time. So this make a comparison between 2006, where one of my students did it, and later on 22, we have also done another problem. So we find that because he has done on 22 about the plastic waste, what it is there, whereas here we studied mainly the lead and chromium. This is chloride, how it is varying, and also the lead, which is, so most of the areas are lead producer assets. So copper, and so most of the uh, elements are much higher than what it is permissible. But nobody worries about that particular one. So what we have done, first thing is we try to uh, model the groundwater and to see that how it is going to affect other nearby residences like Adayar, Velachery, and so on. So, and we really want with the government that there will be a contamination or flood contamination in this thing. We also make an anaerobic bioreactor and aerobic bioreactor. This is one of the scholars who has done the work on this. And we try to find out how the bioreactor, that means take the leachate again back, again put it on the top of the solid waste and try to find out which method works very well. So we found that anaerobic digester was bioreactor was the good one, but aerobic also works equally well. But only thing is aerobic we may have to supply the thing, or once in a day that we may have to uh, shred that thing or topple down the thing. That is what we have done it. So this is one of the research work. He has got PhD long back. So, so the more importantly, if you look at the legacy waste, if you make an analysis, the significant proportion of the soil, it's a fine soil-like material after some 5 years or 10 years. The combustible material ranges from 15 to 18% on the weight basis, and the coarser particles as broken bricks, these are all. But by this time, the lead or the chromium, these are all might have been leached out by from these, and it has gone to some of the groundwater somewhere. So this is where it may be, but still the problem is not solved. So that is what the major thing. So what we thought, how do we go for this remediation? So the first, we have done two things. One is biomining. That was one of the things. The entire waste is treated, entire land is reclaimed. The entire waste fractions are used for some gainful application from industry or normal use and so on. Whereas sometimes we also do the biocapping of the dump site where the geotechnical landfill and so on. So leachate collection and treatment, land is not recovered, legacy waste is not treated, no waste fraction is utilized. So this is just, we are closing the dump site with a biocapping. But there are hybrid model where biomining and biocapping. So that means only certain fraction of the waste is treated, fraction of land is reclaimed, fraction of waste are used for gainful application. Rest of the unused waste is biocapped. So, but more importantly, the biomining of dump site is one of the very good area that one of or all of us can work on. So the biomining is you try to make an assessment, including a thorough site investigation, surveys and waste characterization, systematic excavation of legacy waste and sampling, stabilization by spraying the bioculture to reduce the volume and mass of the waste, process of the excavated fraction, utilization of extracted waste fraction in various gainful applications, clearing and conditioning of recovered land. Even though we say on principle, but it can work very well. This is what we have done. So excavation and inspection, we take away the tire and goods, bulky ferrous metal. Then hazardous material we take separately. And in the excavation, you take the screen and do the biomining and recovered materials, which goes for secondary market, or the screenings and quality testing. Then we try to do the daily cover grading material or approved use offsite. Then the reject waste to energy, re-landfill on the site or landfill offsite. So this is one of the very simple method without much kind of investment that you can do that. The compacted old waste loosened and scrap. So we can use this for a thing, but provided that you also use the bioculture to reduce the layer. So normally we then it is moistened, spread into normal 2 meter high aerobic windrows, turned every weekly 4 times, and volumes reduced by 40% result in bioearth is used in park or to cover road or rail embankment for revegetation. So this is what these are all the waste dump site have been put down up to as a kind of a heap, and then try to change it, formation of windrows and turning arrangements for windrows. So this will be going, but then afterwards this will come back and this will be coming back and so on. So we can easily make a change over the time, and the entire the waste can be taken out. So we take a, I will give you some 2 or 3 case studies. One case study which we were involved on it is Kumbakonam. Kumbakonam is one of the municipality near Tanjavur. So quantity of garbage is assessed by tachometric survey and had occupied 10.5 acres out of the 14 acres of dump site, and the amount spent is around 400 lakhs, and the source of funding came the state government funding. See, these 400 lakhs, you can get that by selling this particular land within no time. So that's why the state government funded the entire thing. The plant is designed to segregate around 14 different aggregates, enabling efficient and responsible disposal for all of them. The plant disposes all aggregates responsibility to the tune of 100%. So that means over the time, this is what, and the 17% of the thing went to cement companies and power plant, and 15% went to pyrolysis plant, 66 went to recycler, and 2% is for reclaimer and recycling companies and steel plants, pipe making companies, and soil enricher to sugarcane farmers, and other thing to sell the RDF to cement companies and power. So almost the entire area have been revised back to the original situation as it. So within, it took around 9 months to finish all those things. But after 9 months, the entire 14 acres have been retrieved, and I think this was a municipality. So municipality got back around. So this area now they are building a government quarters. So this is how it is, how they have done the first stabilization of waste. Then there is a series of machine, trommel, vibro separator, density separator, conveyors, and magnetic separator. So you can just try to the entire area slowly that it has been put on. So that's a first model, which I can say that it is. So similarly, the Nagpur model is on bioremediation. So this was around the municipal solid waste for around 12 lakhs metric tons. 80% of the old dump has been converted into scientific windrows, and a proprietary solution is sprayed over windrows plus garbage. 90% reduction of the stink, managed flies, all those things. So 2009 onwards, it was reorganized, consolidated, and capped in scientific manner into one part of 15 acres area, and reclaimed land was used to set up the processing plant, sanitary land. So this is a Nagpur model where this is made as a windrows and then use a solution to disintegrate or decompose whatever that it is possible. So then the third one is Mumbai model. It is called Gorai. That's a greater Mumbai. This has been the first dump site, which was 1972 onwards, it has been working. Then the companies have come forward, like United Phosphorus Limited, plus with the Netherlands company. So they have made this acquisition of civil work, and with 15 years of O&M, now also it is going, and they got the CDM benefits for this particular project. And here it is more on both complete remediation plus capping also that they have done. So you can just see Gorai model, close-up methodology, how this was the original thing. Then after the volume is reduced, then they have put on the capping, and this is the office and everything that it is. So the mining and biomining is reclaims land that can be used and no maintenance cost is involved. Whereas capping, the land cannot be reused. Biocapping calls for maintenance cost year by year to manage methane and leachate, because the gas also will be coming and leachate also will be coming. So we may have to do the treatment of leachate, and gas also need to be treated, and then or should be scrapped and do it. So comparatively, biomining will be much better that way. But of course, depends upon the volume and also the composition. Sometimes it may not be viable to go for biomining like the Gorai thing. Another Ghazipur dump site, the CRRI, Central Road Research Institute, they have used this entire municipal solid waste for embankment construction in Delhi Meerut Expressway. And this all again, Ghazipur still receives 2,000 tons per day. But they have whatever the available, they have used for embankment construction. So you can also, this may be a good research for especially geotechnical engineers. So this what they have said 10 years, 5 years, and 15 years, and which one can be used for the location. And this was manual separation of municipal solid waste. And this was designed how the embankments and these are all have been road has been designed, and at the below subgrade you can use the municipal solid waste as a thing, and with some intermediate layer and also another municipal solid waste. So this may be one of the good kind of thing that we may utilize it for road construction rather than putting all these new materials and so on. So maybe somebody has to do a lot of research on how the municipal solid waste will behave over the period of time and so on. So this is another, this is a 5-meter height MSW embankment. And bioreactor landfill is one of the good solution where the leachate itself will have a lot of microbes, and that you recycle it from the top and spray it. So automatically accelerated decomposition that it takes place. So this was really wonderful because we have done a lot of experiments and we found that that works very well. So this again, we have anaerobic, aerobic, and hybrid method. So the bioreactor landfill mainly decomposition by leachate recirculation. Decomposition occurred, whereas normally it is around 30 to 50 years it will take for decomposition. But here within 5 to 10 years it can, and it can also solve some of the major environmental problems. So this is how the gas production and all those things with the anaerobic conditions. Delhi is more, they are looking at waste to energy plant, but even though there was some failure, but still these 3 plants are working very well, where the waste is completely converted into energy. Almost around 4,500 tons of waste which are being utilized in these particular sites. So the waste to energy plant at Bhavana, which is Ramke is working on it. So it is a very good, even now it works very well. So this flow sheet for that particular one. So I think I give some way forward. What are the things that it is? It is important that the new legacy sites are not created. Let us, there are legacy sites already around 3,000 sites are available. And if we can come out with some solution for that, that itself. But at the same time, the new waste should not be created. So there also we may have to make a plan how to separate the organic waste, inorganic waste, and then reuse that particular one or recycle that particular one. That is more important. So we need a good source aggregation, 100% waste processing and treatment. Only rejects and inerts should be disposed of in sanitary lands. And this is what it is really required. Developing a sustainable fresh waste management plan, maximum utilization of recovered fraction, utilization of the recovered land, incentives, capacity buildings for the ULB and State Pollution Control Board, and construction and sustainable operation of sustainable land care. So let me, any questions? Hello.
No question. You can go ahead. Is there anyone having question? Or you can continue.
Okay, let me talk about something on life, which is with the permission of the Professor Sridevi, I will just give you a small thing. Life, whether you want to take it as a pain or pleasure, it is depends on you. So the pain is also challenging. So make some good effort to make it as a pleasure, and challenge should be achievement. Pain should be converted into pleasure. That means we have to take little more life, little better, rather than God maybe sabotaging somebody. Or I think that we are Indians are very good in the lifestyle. So let us go back and then try to come out with that's why I put a foreigner on the left side and our great Indian old lady and small boy who is really laughing very well. So I don't know how many of you know about this song, Jolly Wo Gymkhana. So let us be jolly together. So the point is, a child laughs 200 times a day. I don't know if you have not observed, please do that. A youth laughs 100 times a day. But after marriage and joining service, the 100 times become less than 20 times a day. That means somehow we don't want to laugh. And no laughter as growing older, leading to all ailments. So this is maybe beyond after you retire. So on the other hand, when you laugh, it's a real lighting system of face, cooling system of heart, and charging system of mind. So that is what I would really say, that try to laugh. Don't always be very serious in your face, and then try to any problem that we can solve it. So just to smile it or laugh it, I think that needs your life will be better. And the laughing is feel good hormones. Automatically, good hormones will be generating it. In fact, dancing will be making your action very well. So
Yes, sir.
I'm not saying that you need not dance, but you should also dance. But more importantly, clapping. When you clap, at least 39 acupunctures are being activated. So can I ask all of you to clap for 1 minute?
Sure, sir.
Okay, you might have put out in mute, but this is needed. Better to clap. It is not that you are clapping for the person who is giving lecture. You are also enjoying it, and your health also is activated on it. That's why clapping is essential. Then I would say 3 mantras for happiness. Don't get any time tension in any situation. Okay. And there are more examples in our country. Any idea who was the prime minister who never get tension in any situation? This is not subject, it is a common question. Which prime minister you feel never get tension? Indian prime minister.
No problem.
Huh?
No.
Who?
There are no such prime minister.
No such person. No. That answer is not correct. There were two people.
Very Bajpayee.
So the first person is Narasimha Rao. I don't know whether Narasimha Rao never get tensed up in his political life. And he says, if somebody comes for some suggestion, if he tells something, then people will unnecessarily get tension to fulfill his desire. So he says, I won't give any solution. And the solution will automatically, or the problem will get solved within another 3 or 4 days. So he is one good person on that, but he never had any problem. But he has solved also a lot of problems and so on. The second PM, any idea? Who is not like Narasimha Rao, but he is also like that. It's Manmohan Singh. Okay. So he also never get tensed up on any particular situation. Okay. So I am giving example Prime Minister because all of you know about them. There are many faculty members may have these kind of things. So no tension on any situation. The second is no worries. Do not turn your difficulties into worries. So if I am not able to do that some work, then that difficulty should not become a worry. So that means you should find how we can solve that particular difficulty rather than convert that into worries. The third one, do not turn all your desires into needs. So this is one thing very important in our life, that whatever we desire, we wanted to make it as a essential needs, which is not needed. And it seems if you start pronouncing Vitala, Vitala, your body is getting activated quite a lot. And the Tibetan proverb says, eat half, walk double, and laugh triple, and love without any measure. That is the secret to. We have a lot of Tibetans live for a long time, mainly because of this. And there is a Japan proverb, it's called Hara Hachi Pu. Mainly it says that you never eat beyond your 80%. Unfortunately, our Indians will eat up to the full stomach. That itself is not a correct thing. So 80% you should be able to stop. So when you make love or do activities, so there are so many, if you are appreciating it, you get dopamine hormone will be coming. And also uh, if you love oxytocin, work with the joy, endorphin, and if you are helping somebody, you get it. So by doing all these things, you will be able to make happy. You can also be happy and making others also happy as well. So on the other hand, even water has feelings. If you the water molecule changes with words and times. So if you go and tell to the water that I will kill you, then it changes a pattern like this. These people have invented from Japan. And the moment that you say, I love you, then you will get a nice thing. So when your water can do all those things, why don't you do with your better half or your family? Tell that I love you. That will be really good for you also. Okay. So this is very important. The environment is where all we live, whereas development, what we all do. But the environment is like mother to be cared with love, whereas development is like wife. I don't know how many of you have got married, but it's like wife to be loved with care. So there is a lot of difference between environment and development. So we need both the things, but at the same time, many people are not able to do both things very well. Okay, but you can do that. That's where the sustainable development comes into picture. So the environment, we need green and clean environment and cheerful. But unfortunately, we are ranking out of 180 nations, 176 as far as the environmental performance is concerned. So we are not clean because the eighth most polluted country, no toilet for 19% of the people, 70% of the surface water unfit for consumption, and PM 2.5 air pollution is 10 times greater than WHO. And we have 21.7 forest cover instead of 33%. 33 is one third of any country where if it is forest is there, then that country is environmentally good. And also for cheerful, we are also ranking around 126 out of 143 nations. Social support, income, health, freedom, generosity, and no corruption. These are all happiness index. So this we need to improve for our country as a. But on the other hand, you can be proud of our country because that's a cradle of human race, birthplace of human speech. Actually, the first speech is mainly originated from here, mother of history, grandmother of science and technology, great grandmother of culture and civilization. And we have it in our country practice, the nature has been worshipped everywhere. A tree is always worshipped on stage of marriage and then planted by married couple. This you might have seen in South India, it is very common. And bamboo cutting is only 3 days a week, so that it is not completely eroded. And they use only a medicinal plant only on Saturdays, and banana is not consumed during the period of Durga Puja. So they try to create the practice to save the thing. So, and only thing is, I wanted to tell it shall be the duty of every citizen of India to protect and improve the natural environment, including forests, lakes, rivers, and wildlife, and to have compassion for living creatures. Please remember, this was written in 1950. So, by the great Bharatna Ambedkar. So, at that time itself, we ourselves are good in protecting the environment. Unfortunately, our solid waste is not being taken care of this particular thing. So, we are rich in biodiversity, and we are the only country having tiger, leopard, and lion with our thing. And 3,000 medicinal plants are being available in our country. So, but we are not economically rich. That's the only thing. But I wanted all of you should reverse our environment, make it green and clean and cheerful. You can see this picture, and if you just reverse it, you will become a smiling face. So, what I wanted the environment by doing a good municipal solid waste management, we can make it as a cheerful thing. Now it is like this. So let us all join together and make the solid waste not a problem, but as a place to do. So finally, I would like to share this thing, especially many of your teachers, how to teach Newton's law. This was a very nice thing which I like it. A cow was walking, the Newton stopped it and it stopped. So he wrote his first law: an object continues to move unless it is stopped. So are you able to recall the first law? Then he gave a force by kicking the cow. It gave a sound ma. Then he formulated the second law, F equal to ma. So this is what all of you know. After some time, the cow gave a kick to Newton. Then he formulated the third law: every action has an equal and opposite reaction. So if you teach like this, nobody will forget the Newton's all the three laws. So you should innovate some new method, new way of teaching, so that the current student are able to understand the thing. So I wanted that this story is, and our school days, people used to, or your teacher might have taught that old crow saw a small water and it bring pebbles, and then put in everything to make the water to come up. But now the modern crow is bring a straw and then take the water. So similarly, now things have changed quite a lot, but we should do something good for our nation, with especially on solid waste management, so that you are solving not only the solid waste problem, but also the surface water pollution, groundwater pollution, and air pollution, and land pollution. Everything is you are trying to solve that. Okay. So thank you very much for giving an opportunity to think. So let us build a zero landfill nation for our future generation. Let us not leave that as a legacy. Thank you. Thank you very much. So I hope that I have enough time. So if you have any questions or something, then I am here.
Thank you very much, sir. Now, participant may ask questions.
So now stage is for participants. So any of you, all of you are welcome for question and answer session. If you have any doubt, queries, you please ask. You unmute your audio and you can ask. You need to write.
Good evening, sir.
Yeah, good evening.
So, am I audible?
Yeah, yeah.
Okay. First of all, sir, I'm Dr. Swati Patil from Sandeep University, Nasik. Thank you for sharing a lot of knowledge regarding the landfill emissions, landfill gases, and capping. Just I want to ask one question, sir.
Yeah.
For these closed landfills, can we
Uh,
go for the redevelopment by using the stabilizations?
uh, you mean biomining, you are saying?
Suppose capping landfill totally is closed. So that closed landfill, can we go for
Uh,
the redevelopment by using the stabilization techniques?
yeah, yeah. We can go for on the top, provided that it has been done in a very proper way, especially capping. They should have done very well. The second is the waste also has been protected with a good liner. Now it is coming. You might have heard about the first problem of the Love Canal. Love Canal is a place where they dumped it and then cap it and then started a community. And then after some time, these damages from the war chemicals, they are all coming into the thing, and many people have a lot of problems. So, but now our rules are very good. So, wherever the hazardous waste are being dumped, there is a clear check at every point of it. And we also do a lot of work on that particular thing. We can go ahead on developing on the top of it, but only problem is it takes a lot of time to complete removal of the gas. So even if you are sitting there, there will be a small gas emanation that it will be there on the landfill. So that you can't avoid it. So that is why it is not completely recommended. After your capping, another 10 years at least, you cannot build a redevelop that particular one. So after
Oh,
10 years, after observation that there is no gas is coming out, then you can go for some redevelopment into whatever it is. But you can't do a building on the top because the foundation and all those things. Only thing is you can create as a recreation place or some kind of other thing that may be better rather than go and build a big building there. That's what. On the other hand, the biomining will be much better. You remove the entire thing and build a thing which maybe there is no problem as it. But capping afterwards, minimum 10 years that it is needed to go before you come out, take any development or redevelopment activities. Okay, I hope that
okay.
I
Thank you,
have.
sir. Thank you,
Thank
sir.
you.
Uh, Are there any more participants having doubts and confusion? Are there anyone who ready for some discussion? Dear participants, you can see 80, 90 number of participants. Only Swati Patel had her confusion cleared. So I think there is no one with questions. So
No, I would like to
yes,
say
sir.
one small advice.
Yes,
You should
please.
all try to ask questions. That's more important. Unfortunately, our school itself, whenever somebody asks question, the teacher says you are overdoing it. So that's where we never ask questions in the thing. I'll tell you a
Sir,
small story where
hmm,
why we need to ask questions.
hmm,
So one time a maths teacher came to the staff room with a smile. Then the colleagues have asked him, how come you are very normally maths teacher are very strict and kind of a thing. So he told today something happened in the class. Then he was trying to narrate what happened. He told that today I started making a derivation of Laplace equation. All of you know that Laplace equation, dou square x or u or whatever it is, dou x square plus dou square u by dou y square equal to 0. So when he was making some 3 or 4 stuff, one student got up and then said, Sir, I did not understand anything what you have said. Could you please repeat from the beginning? Then, having a student asked, the teacher repeated. Then after he comes to that fourth step, he asks the student whether it is understood. At that time, the student told, still I have not understood, but you can go ahead, sir. Then he went for another 2 steps. Some other student got up and said, Sir, I didn't understand anything. Could you please repeat? And he told, when I was doing fourth time, the repetition of derivation, I myself understood how the derivation has come. So sometimes allow the students to ask questions so that you also learn, the teachers also learn. So don't try to stop them asking questions. By asking question only, you can learn a lot. Okay. So that's
sir,
my, yeah, thank
thank
you.
you for your advice, sir. So can I question? I have some doubt.
Yeah.
Uh, so landfill, it has two major components. One is like liner system, another is capping system. So why that capping system is used
Uh,
at the end of the full capacity of the landfill?
yeah.
Why?
What are you asking?
Why cap system is used over the
Uh,
buried waste? And
yes,
that
yes.
cap
We have
system,
to. That is as per the design that they have to do the capping. So
what is the
without
reason?
capping.
Yes,
If you
sir.
don't do the capping, then
Hmm.
during the rain, that it may splash over and it may go down and then create the pollution.
It's
So
leachate formation, then that leachate will go
yeah, right.
downward
Leach
and
it. Yeah,
leach.
it is not leach it, but what it comes as it may be like a overflowing, right?
Okay.
And especially the gases also will be coming, and it will be if you don't cap it also, there is a possibility for other damages that it may come. Sometime
Okay.
suddenly it may be the water if it is started entering. After
Hmm.
some time, there will be a small failure, so
Hmm.
that the entire one portion of that will go down. Then that will be much more dangerous than this particular one. You might have seen in Sri Lanka, this kind of one side slip has occurred and it is like a landslide. So the people who are working did not know that it is falling down. At least around 10 to 15 people died at that particular point of time. So that's also one of the reasons that you have to do the capping, so that there is no water entering and then trying to keep that geotechnically, it's a weak thing that should not create. So that is why the slip circle or the slip thing that we may have to calculate on that. If you don't do the capping, this will be possibly to occur this land, not landslide, the waste slide also may occur.
And
Of
also
course, pollution. Yeah.
we know there are a lot of types of cover system, and in terms of number of layer.
Yeah.
But sometimes in top we are having surface layer, then drainage layer, then gas collection layer, then CC layer, then foundation layer. So these many layering sometime we may need depending upon the weather condition of the place. So what is the use of that drainage layer? How do we
No, no,
use?
actually what you put a drainage is mainly from the decomposition of the waste, whatever the leachate is generated, for that only the drainage system will be there. The drainage system is not for rainfall falling on it and all of them are getting it. No. So in fact, you are supposed to close every time. If there is a monsoon is going to come, before that you may have to close even if it is halfway through. That that means we never expect the rainfall is falling into the landfill.
Waste.
So it is only the drainage or the leachate due to its own decomposition or some reaction, whatever it is taking place over the period. For that drainage only, leachate drainage only, we have the drainage system, not for the rainfall drainage. Okay. So
And
we don't consider that.
for drainage layer, mostly people use porous kind of materials like sand or some gravel. But if we use that, maybe we need to place some geomembrane or something just under
Yeah, yeah.
the drainage layer to drain out the water, infiltrated water, laterally out of the uh, buried waste. So, what material do you suggest? It will sustain for longer and the purpose will be served. Is there
No,
any kind
depends
of
upon the type of waste. If it is a hazardous waste, we have to use the HTP liner.
okay?
Okay. There is no
Okay.
other alternative. Or your geomembrane, those things are only for holding that particular thing in that position and so on. But that does not prevent anything. Whereas HTP liner is time tested and over the time period, even if it is under the salt, we have done a lot of experiments under the worst condition of industry waste salt. If I put on the top of the HTP liner, it really works very well. So HTP liner, if you do that, there is no problem as such. But the other kind of liner, any other liner, it may not be so. Now you can't have your own option because CPCB gives a very clear guidelines. So especially hazardous waste, you should have two liner system. And for municipal waste, it is one liner system that it is really needed. So that way we may have to go for that particular. There is no compromise on those things. Okay. So that's
And
what I would.
also, in some cases, people plant vegetation or fruit on the top of the cover, means on the surface layer, uh,
Uh,
because that land is, if well prepared, then that can be used for cultivation or farming. So, do you suggest that thing is good? Means no
no,
health issue will come out of it because you know
no,
some toxic
the
element.
you can grow some trees and so on the sides, but
Yeah,
growing a tree on the top of the landfill or capping is not advisable
because it
because
will.
yeah, because the salt or whatever it is, they we can't guarantee they are all good. Yes,
Hmm.
and plants are very capable of sucking all the
Ah,
salt.
yes, yes.
So it may be wanted or unwanted material or hazardous salt. These are all will go into that particular one. So finally, if it yields and that fruit or that grain will contain some of these particular things.
Okay,
So
okay.
it may not be possible. So we don't encourage on this particular one. Okay.
Hmm.
So in
Okay.
fact, I can tell you a story.
Hmm.
There was one person who was exporting the milk powder or the egg powder. So
Hmm.
he makes out of the egg, make a powder and then export it to countries and especially USA and UK. One time he sent a full lot by ship and they found that the egg powder contains some heavy metals which are not supposed to be there.
Okay.
Then the entire lot was rejected, and that fellow could not bring it here also. So then we have tested the samples, and finally we found that they have grown that particular uh, crop, whatever it is, the crop for the uh, fodder thing, that was at a chemical waste dumping site. So that was a major problem. So the plant has a capability to take away all the minerals and then put it in their thing. So the plant and grain was taken by the hen and it has gone to egg and from the egg it has come to egg powder. So that's why better not to grow on that any food items or even the fodder item on that particular. Okay.
Yes, sir. Yes, sir. Thank you very
You
much,
can
sir,
use as
for
a playground. You
yeah,
can use
yeah.
as a park.
Ah,
That
yeah,
will
yeah.
be better rather
Well,
than make it as
ah,
a okay.
farming or cultivation. So,
Okay.
yes, sir, I understood. And thank you for helping me to understand. So, are there anyone having some doubts or confusion?
Hmm. Hello, sir. Just one question I had posted.
Yeah.
So, one point during this presentation, you mentioned that in one case they use this municipal solid waste as a building material, right?
Yes.
So,
Yes.
what was the composition of the waste, sir?
No.
Which
No.
made it
No.
suitable
Not
as a.
not
Hmm.
as a building material, but
Ah,
what you do is it is used as a embankment filler material. Embankment
right,
layer
right, right.
filler material, not
Oh,
as
filler
a
material.
building material.
Oh,
Okay.
okay, okay, sir. Right, right. So it had like like soil and rock, those kind of things, or because that part I somehow missed that part. So,
Okay. Right.
right, sir. Okay.
Is there anyone? So, sir, I have something to share. Actually, you share your brief CV with me lately, and also we had some issues to start our inauguration and the first day. So, can you please give me chance to share your brief discussion, brief introduction? So, for those who don't know much, Professor Dr. S. Mohan, let me share. Professor Dr. S. Mohan is currently Vice Chancellor at Puducherry Technical University, that is in Puducherry, since December 2021, under deputation from IIT Madras, where he serves as Institute Chair Professor in Environmental and Water Resource Engineering Division of the Department of Civil Engineering, Chennai. He is also serving as the professor in the Department of Civil Engineering at IIT Madras, and he served as the head Department of the Civil Engineering, IIT Madras, Chennai. He completed his bachelor's degree from Thiagaraj College, Madurai, and obtained his master's in water engineering in 1983, and he completed his PhD in water and environmental engineering in 1987 from IISc Bangalore, and become a faculty member of IIT Madras in 1987. As of July 2023, he has published over 275 research articles and technical reports on several areas of environmental and water resources engineering, including water, waste treatment technologies, environmental nanotechnology, environmental impact assessment, water and air quality modeling, contaminant transport in surface and subsurface water system, sustainability engineering, reservoir operation, water resources optimization, waste to energy, waste to materials, and solid waste management. The HI index and citation index of his publication are 29 and 3291 respectively as of July 2023. He has also conferred with more than 21 awards of his outstanding contribution in the area of environmental and water resources engineering as well as to the engineering education. The awards include Paul Penny Quick Eminent Engineering Award, Institution of Engineers Medal, Indian Water Works Association IWWA Award, to name a few. His name has been listed in the world's top 2% scientists working in the field of environmental engineering, published by Stanford University consecutively for last 4 years, that is September 2020, November 2021, October 2022, and November 2023. Professor S. Mohan has a total teaching and research experience of 37 years, and he was a postdoctoral fellow of Cornell University, Ithaca, New York, USA. He was also visiting researcher at the University of Illinois, Chicago, Brandley University, USA, University of Colorado, Boulder, USA, then South Bank University, UK, United Nations University, Japan, in University of Nottingham, UK, and Malaysia campus, National University of Singapore, and so many. Professor S. Mohan served as chairman, State Expert Appraisal Committee, SCAC, Tamil Nadu State from November 2018 to October 2021. And he served as member in Expert Committee on Industrial Projects, MOEF, BOI from 2000 to 2010. He is currently serving as an independent director of Tamil Nadu Small Industries Development Corporation Limited, SID SIDCO actually, that is Government of Tamil Nadu. He has also carried out around 25 national and international sponsored research projects and 126 national consultancy projects. He also served as director NITTR Chennai from 2009 to 2014 with additional charge as the director, Central Institute of Classical Tamil, Chennai. He is also the member of Board of Governors of IIT Madras since January 2022. And Professor S. Mohan has served as the chairperson of International Water Association, IWA, India, for the period October 2018 to September 2022. And also he served as member of Membership Engagement Committee, MEC of IWA. Currently, he is the member of Board of Governors of International Water Association since September 2021. Sir, you are huge, sir. We love you, sir. We are proud of you, sir. We are
Thank
really
you.
proud of you. We are proud of you, sir. And we are very much happy and thankful to get you, sir, for this FDP. And this is the first FDP from my side as a coordinator. Sir, bless us so that we can conduct more in future.
Okay.
Thank you, sir.
Okay.
Thank you. So
Okay.
nice to
Thank
have
you
you.
very much. Thank you all. Thank you all.
Thank you.
Especially
Thank you.
Professor
Thank you very
Devi.
much, sir.
Thank you
Thank
very
you,
much.
sir.
Right. Thank you. Yeah, please.